Hello and welcome to the unit on data structures. This is the part 5 of this particular unit, and in this class we are going to discuss about implementation of stacks using linear list. All of you already have the basic idea of stacks. If you do not have, you can look into the part 2 of this particular unit and you will get the basic idea about stacks. The aim of this particular lesson or this particular part, that is part 5, is to implement the operations on a stack using linear list programmatically. For that, we'll be using the programming language Python. So let's see what are the operations in a stack that we are going to implement. So the first operation on a stack would be push, second is pop, third is pick, and fourth is displaying the elements of a stack. We already know what are push, pop, pick and display stack, but here I am going to revise it a little bit. What I am going to do, I am going to segregate the entire program. Actually, the operations on stack, it's a little big program, so I have segregated it into certain parts. I'll explain it to you in parts and then I'll write the complete program and I'll show the complete program live in this video itself. So stay tuned. So let's go to the first operation, which is push, and along with push I am going to discuss about pop also. What is push in stack? Insertion of a new element into a stack is called push. So if we add a new element into a stack, it is known by the name of push. And deletion of existing element from the top of a stack is called pop. As we already know, stack is such a linear data structures where the element are inserted and deleted only at one end, known as the top of the stack. If you want to know more details about stack, then you can go and check out the part 2 of this particular chapter. Now let's try to revise what a stack is a little bit. So at the beginning, when the stack is empty, this is the diagram of a stack which we often draw in order to explain the students. So the value of top is usually -1 or none when there are no elements into the stack. Let's say we want to insert an element into the stack. So my top equals to -1 means the stack is empty. Now let's say we want to insert an element 8 into the stack. As I have already discussed, insertion of new element into the stack, it is known by the name of push. So 8 will be pushed into the stack. Now when an element is pushed into the stack, the top value is incremented by 1. So how to represent it? We can represent it as top equals to top plus 1. So what was the value of top initially? When the stack was empty, the value of top was -1. So -1 plus 1 is 0. So currently top will be pointing towards 0. Now let's insert or let's push another element called 12 into the stack. This time the value of top will again be incremented by 1, that is 12. Now let us see how the operation of pop will take place. In case of stack, always you should remember this thing, that elements are inserted and deleted only from one end, known as the top of the stack. So which element will be removed? Even if we want, we cannot remove 8 from the stack. We have to remove 12 before removing 8. So if I give the instruction of pop, then 12 will be removed from the stack. And as 12 is removed, top will be decremented by 1. So top will become top minus 1. That means now top will be pointing to 0. Then again, if I give the instruction of pop, this time pop 8 will be removed from the stack and the top will again become -1. As I have already said, when there are no more elements to be deleted from the stack, that condition is known as stack underflow. Okay, I have discussed about underflow, overflow in part 2. You can refer to that anyways. Now let's see how we can implement the push operation programmatically via Python. So the name of this part is we have to implement stack using the concept of linear list. So what we can do, we can create a linear list by a variable. Let's say the name of the variable is stack. So I can initially create an empty list because initially the stack will be empty. Then I will add elements into the top of the stack. That means at the top of the linear list. How to add elements into the linear list after linear list creation? For that we have a function known as the append function. What is the syntax? The syntax is list name dot append, and within bracket we have to give the value. Let's say I want to add the element 11, so I'll write stack dot append 11. As I press the enter key, then if I want to see the updated stack, then I'll just write stack and press the enter key. As you can see, I'm getting 11. If I want to add more element, I'll use the append function again, stack.append 22, let's say. So this time if I display the stack, I'll get 11 and 22. So now what is the value of top? The value of top is 1. Why 1? Because in case of linear list, as you already know from your concepts of class 11, the indexing starts from 0. 0, 1, 2, like this it will go. If I add one more element, I can always use the append function again, and if I write stack again to see the updated value, now I'm getting the updated value. Now these are the indexes associated with these values. The index of 11 is 0, index of 22 is 1, and the index of 33 is 2. What are these? These are the indexes. Now what is the position of the top now? The position of the top will be the current element, because as you know, in case of stack, the elements are accessed using a technique called LIFO, called last in first out, and the value of top will be the value of the index of the last element. What is the last element or the latest element that's inserted into this stack? The latest element inserted into this stack is 33. So top will be pointing towards 2. I hope it is clear. So how to find out the value of top programmatically? You know a function called length, len. Len function, what it will do, it will count the number of elements in a list and it will return the number of elements. So if I give len stack, it will return me the number of elements in the stack. So here if I give len stack, how many elements are there in the stack? There are 3 elements in the stack. Those are 11, 22 and 33. But top will be 1 less than the number of elements because the counting starts from 0 in case of indexes. So I can find out the top by len length of stack minus 1. Therefore, the top value will be 2. Let me quickly show it to you programmatically. So this is my idle. So if I have a stack, initially the stack will be empty. I am showing it twice because this is a very important program. So if I want to add elements, I'll use the append function, stack.append, let's say 11. So if I want to see the updated value, I'll give stack. So if I want to like add one more element, I can continue doing that. If I want to add another element, sorry, dot is missing, stack.append 33. If I want to see the updated stack, this is the updated stack. So what is the current position of top? This is the current position of top, that is 3. So if I use the len function, len stack, len, what it does, it will count the number of elements in the list and it will return it to you. So there are 3 elements in this list, so 3 is returned here, but we want the top. What is the position of the top? 0, 1, 2. So current position of top is 2. That means it is 1 less than the length always. So what we can do, we can take any variable. Let's take the variable as top. Top equals to length of the stack minus 1. So if I want to find out the top, now as you can see, I'm getting the correct value of top, that is 2. This is the process which we will be applying while implementing the push. Now let's see how pop will be implemented. What is the current status? The current status is that these are our elements, these are the indexes, and top is pointing to 2, to the index 2. How to find out the top? Length of stack minus 1, so top is 2. Now pop means what? Pop means removing of elements. Now from where the elements will be removed? Elements will be removed from the top of the stack. So what we can do? We can write stack.pop function. These functions we have already got in class 11 in the chapter on linear list. So stack.pop, it will remove the last element that is inserted. What is the last element that is inserted into the stack? It is 33. So 33 will be removed from the top of the stack. So as I give stack.top, it will remove 33. Now you have to update the top. How to update the top? You can write top equals to length of stack minus 1. So you will get the new value of top, that is 1. Why it is 1? No, why not 2? Because 33 is already removed. So top equals to top minus 1. That becomes the top as 1. If I again give stack.pop, this time 22 will be removed, and if I want to find out the top, the value of top will be 0 because there is only one element in the top now. Now next is peak. What is peak? Peak means displaying the topmost element of a stack is known as peak. So this is the current position of the stack before popping out. These are the indexes, and this is the current position of top. How to find out the top? Length of stack minus 1. So top is 2. Now if I want to display not the index of top but the element which is contained at that index. What is the element which is at the top of the stack? It is 33. So how to find out that? You can find out that by accessing that particular value of top. So if I write print stack top, it will display the element which is at the top of the stack. Okay, all right. So I'm again explaining peak. So let's assume this is a stack and there are elements 11, 22, 33, 44. These are the indexes. Where is the top located? The top is located at the index 3. So if I give the operation of peak, peak means displaying the topmost element without removing it. We don't have to remove it. Without removing, we have to display the topmost element. So peak will give me the answer as 44. How have I done it? At first I have found out the top. How to find out the top? Length of the stack minus 1. So what is the length of this stack? How many elements are there? 4 elements. So 4 minus 1, that is 3. As you can verify from here, top is how much? Top is 3. If I want to access the element that is at the top of the stack, then I'll give the instruction as stack. Let's say this stack is contained in the variable stack top. That means what is located at stack top? 3. So stack 3 means the element which is contained at that location. Which is the element? It is 44. This is the method that I'll be using while implementing the operation of peak. Now let us go and integrate all these things into a single program. So let's go and implement and write a program in Python to implement the operations on stack. This is a very important question from examination point of view. Okay, it may also be asked in various vivas and interviews. So let's implement stack. Implementation of stack. We are implementing it via what? We are implementing it via linear list. So let's create a function called isEmpty. Okay, here I will what I'll do, a stack will be created somewhere in the main program, and if stack is an empty list, I'll return true. You'll understand the complete program once it's done. Else, so this function is basically used to check whether the stack is empty or not. So if we have an empty list, then it will return true. That means the stack is empty. Otherwise, what it will return? It will return false. True and false are Boolean keywords in Python. Next function, we are doing it by Python so that segregation is possible. Then I'm implementing push. For implementing push, let's take the stack. It's located in the variable s in this particular program and the item. The item will come from the main program. I hope that you have clarity about the chapter on functions. If you do not have, you can look up my videos on working with functions. Then how will I add elements to the stack? By using the append function. So s.append, what will I append here? I'll append the item here. Alright. Then how to find out the top? Top is length of stack minus 1. So we are done with push now. Let's use the function pop. Pop is used for removal of data. Okay, so I'm just giving some comments here. Push means adding elements at the top of the stack. Let's go to pop. What will it take as the parameter? It will take the stack as the parameter. At first, in case of pop, we have to check whether the stack is empty or not. Why do we have to check whether the stack is empty or not? Because if the stack is empty, can we remove any element from the stack? No, we cannot remove any element from the stack if the stack is empty. So that is to be checked first. How to check it? If we are calling the isEmpty function. If is, okay, through isEmpty function we have to give a parameter here. If isEmpty s, then it is known by a term called stack overflow, as I have already mentioned a few minutes back. If the stack is empty, no elements can be removed from the stack, and that is known by the name of stack overflow. Else item equals to, if the stack is not empty, we can pop it out by using the pop function as I have shown it to you a few minutes back. So if length of stack equals to 0, when length of stack will be 0? When there are no more elements to be removed from the stack. And if the length of stack is 0, then top will be what? Top will be none. I hope you remember from the chapter on Python fundamentals that none is a keyword. Else, if length of stack is not 0, then we can find out the top. How to find out the top? By length of stack minus 1. And after deleting a particular element, the item will be stored in which variable? It will be stored in the variable item. So what we are going to do? We are going to return the variable item here. Okay, so push and pop is done. Let's go to peek now. Peek means, so pop means removing element at the top. Next is peek. What will it take as the parameter? It will take the stack as the parameter. The stack will come from the main program. Okay, main program we are going to write at the down. So here also, for displaying the topmost element, we have to check whether the stack, something is there in the stack or not. How to check that? By using the isEmpty function. So if isEmpty stack, then what will print? Will print stack underflow. Okay. Else, if it is not empty, we can display the element at the top. At first, let us find out the top. How to find out the top? Top equals to length of stack minus 1. And what will return? Will return the element at the top of the stack. How to return it? What is the variable where the stack is stored? It is in the variable s. So if I return as top, the element at the top of the stack will be returned to the main program. Next comes the display function. Display function will be used for displaying the entire stack. So for that, let's check whether the stack is empty or not. IsEmpty is a common function which is used everywhere except the push, because before going to the operations, we have to ensure that the stack is not empty. It can, so for that we have created a separate function called isEmpty. Now if it is not empty, what I am going to do, I am going to find out what is at the top of the stack. So top, how to find out the top? Length of stack. It's long, but it's not difficult. It's not a difficult program. So top equals to length of the stack minus 1. Now how to print out? Let's display the topmost elements separately, and then the rest of the elements we are going to display with the help of a for loop by taking the step value as minus 1. So print stack top. In this way we can display the top. And why am I displaying the top separately? So that I can mention the topmost element here. So then it looks more user friendly and much better. Then for the other elements, what I'll do, I'll display the elements. So for I in range, the second element, if I have to access the element after the topmost element, I can write top minus 1. We have to go backwards by minus 1. If I want to go backward, what will be the step value? The step value will be minus 1. And then simply I will display the elements which are contained in the stack except the topmost element. Why except the topmost element? Because topmost element I have already displayed before the loop. So that's all with the functions. Now I am going to write the main program. So initially I have made a empty stack and I have initialized top to none because initially the stack is empty. Now if I have to run it repeatedly, I'll just give answer equals to y. Answer equals to y is given. I hope you know the concept of while loop. It's a concept of class 11. If you want to revise those concepts, you can check out my earlier videos on class 11. It is in the chapter called flow of control. So here while answer equals to small y or answer equals to capital Y. This I have given because I want these operations to repeat itself. I'll ask the user whether the user wants to repeat these operations or not. So then it's simply a work of display now. Operations in a stack. Let's print the operations one after another. Print first will be what? Push. Then the second operation I'll give it number 2. This is a menu based program. Pop. Then third operation will be tick. Then let's create the fourth operation. Fourth operation will be to display the stack. Display stack means I'll display all the elements of the stack at a particular moment. Print 5 I'll give for exiting from the program. That I'll just simply give the break command. Now I'll take a variable ch which will receive the numbers. Ch equals to int input. Enter your choice. It's from 1 to 5 so that the user doesn't make any mistake here. Okay. Then next, if now I'll be filtering and calling these functions one by one. If ch equals to 1, what I am going to do? See, first operation is push. Now the function push is expecting the stack and the item. So from where will I get the item? I'll have to take the item from the user. So item, let's take it from the user. So item equals to int input, enter the item to be pushed. Okay. After that, let's call the push function. You have to write it exactly push. It is expecting the stack and the item to be pushed. So let's give them those things. Push. The first thing is s. So this empty list will go fire this function and the item. Item it will take from this particular variable item. Okay. Now next is elif, because more menu are there. elif ch equals to second is pop. So here I am going to, what it is expecting, it is expecting the stack. So let's send the stack here. From here, push pop, I have sent the stack from here. So after that, you can see at the last of the pop function, return item. Return item means whatever will be the item that will be popped, it will be returned to the main program. And you know from the concept of working with functions of term 1 that if something is returned, then you need to have a variable which will accept it. So here I have given the variable as item. Okay, after that, so where will the final popped item be located? It will be located in the variable item. So popped, I can display the item here. Okay, elif ch equals to 3. Let's call the peek function. Peek function is also expecting the stack as an input and it is returning the value of the top. So since it is returning for receiving it, we need to have a variable here. So let's say the variable is item. Item equals to peek s. I'm sending the stack from here. So where will the final answer be located? It will be located in the variable item. So let's display that item here. Topmost item is comma item. Next is display stack. What it is expecting? It is expecting the stack itself. So let's display it. If ch equals to 4, we'll display the stack here. So is it like sending anything to the main program? It's not sending anything to the main program. There is no return statement. Therefore, I can call it directly. There should not be any variable which will catch it. Now, what does the fifth menu says? It says that we have to exit elif ch equals to 5. How to exit? For this, you can either use the exit function or the break statement. I prefer to use break. Now, if the user types anything other than 1 to 5, then we have managed that condition also. So for that, we can just write invalid input. Please try with a valid input. We can like give this instruction. Okay. Now, this loop will continue to run until answer is equals to small y or capital Y. For controlling that, we will take the same variable answer and we will ask the user that do you want to run the program again? Yes or no. The user will type either yes or no. That means y or n. So our program is done. Now let me save it in some location. I'll save it. Let's say I'll save it in this location only. I've saved it by name. Now let me run this program. Invalid syntax, I made some mistake. Yes, for comparison I should use double equals to. Again invalid syntax. Let's see. Yes, here also I have made some mistake. It's a big program, so some mistakes maybe there. Yes, now it's correct. Operations in a stack. Let's try to do the first operation, that is push. So I'll press 1, enter the item to be pushed. Let's say I'll give 11. Do you want to run the program again? Yes. Let's push another item, enter your choice 1, enter the item to be pushed. Let's say 22. Do you want to run the program again? Yes. Let's push a few elements. 1, let's push 33, program again, run. Yes. Push again, let's say 44, run the program again, yes. Now let's say at first I'll display the stack. So I'll press 4 here. So as you can see, the elements are displayed here, which is 44 and 33 here. Okay, so let's see, have I made any mistake here? In the top, print si top -1, and here what have I given? Top -1. Oh, okay, sorry, here I have made a mistake. That's why all the elements are not displayed. It should be -1. Okay, yeah, it should be -1 because we are traversing in the backward direction, right? So what I'll do, I'll just exit it and run the program again. Okay, let's run it again. Push 1 item to be pushed, 11, run the program again, yes. Push item to be pushed, let's say 22, run the program again. Push item to be pushed, 33, run the program again, yes. Let's display the stack 4, yes, it is displayed correctly now. The element at the top is 33. See, while I entered the elements, 33 was the element that is entered last. That means it is the last in. So that will be the element at the top. So which is the topmost element now? 33 is the topmost element. So stack is being displayed correctly. Now let's run the program again. Yes, let me pop out the element. So enter your choice 2. It is displaying popped is 33. Do you want to run the program again? Yes, let's display the stack 4. Now you can see 22 is the topmost element. Run the program again, yes. Let me push another element, let's say 55. Run the program again, yes. Let's display the stack. So it is displaying 55, 22 and 11. Okay, so let's peek now. Peek is menu number 3. Peek means displaying the topmost element. Which is the element at the top? It is 55. So 55 should come as the answer. Let's see. Yes, it is displaying that the topmost item is 55. Okay. Do you want to run the program again? Yes. Now let me exit from the program. So I can just press 5. I could have exited by pressing N also, but 5 is one of the menus. So I wanted to show you that one also. So as I press 5, you can see that I am redirected back to the interactive mode. So these are the operations in a stack. I hope that it is clear. You should watch this video slowly, and if there is confusion at any part, let me know, and you can rewatch the video several times for a better clarity and understanding. So that's all for the day. I hope this video will benefit you. Thank you very much.